Hey, Roberto, how's it
Hey,
going?
hello.
You know,
Welcome.
Thank you for
it's
having me.
it's going really, really well, as you can see.
It's fun. It's remember what Bernard Borges says, right? Everything
Everything
breaks all the
fails
times. Yeah.
all
So
the
we have
time.
to be prepared.
That's right.
And here we are, still live.
Well, how's it going, Roberto? You want to introduce yourself to the stream, please?
Yeah. Hello, everyone. My name is Roberto Luna Rojas. I go by Robert, actually. It's been there for a long time. I'm a specialty solutions architect with AWS, with working within memory databases, both Elasticache and MemoryDB. Really glad to be here with you.
Very nice, very nice. Yeah, we're keeping the database theme going here. We're gonna hear all about MemoryDB, and we already actually saw in chat earlier. Our friends in chat already set us up with a really great intro question. They had yet to hear about MemoryDB. We had somebody in chat asking, "What's MemoryDB?" I've never heard of that. I thought I knew every AWS service. So, do you want to give us just a quick overview? Do you want to pull up your slides at this point too?
I do have some slides that will help understand what it is, right?
All
So
right.
MemoryDB is the fastest NoSQL fully durable in-memory database. What does that mean, right? Like in memory and durable, right? Like, well, uh, as we do with AWS, we work backwards from what customers ask us, right? So we have all these purpose-built databases that have a specific use case. And we have two in-memory services, Elasticache that works for ephemeral or semi-durable data. But when you do require durability and you're using Redis, for example, that's what we have in-memory database, MemoryDB. And we like to see it, that's why I like this slide, is very visual, right? So Elasticache for MakersDB, for example, is the first engine that was supported over 11 years ago, is for fully ephemeral use cases, right? So you better have some way to retrieve your data from a source of truth because there's no persistence. Data goes in memory and there's no backup, there's no replication, nothing, right? So it's good for a lot of simple caching use cases. But if you think about it, let's say you are using a cache to front your source of truth, your backend database, whatever that might be, RDS, DocumentDB, etc. So you don't want to have to rehydrate all the data. That's what Elasticache for Redis comes in as a semi-durable store. That means you have snapshots. That means up to 20 times a day, you will store data from memory to a managed S3 bucket. But that could still potentially lose up to 70 minutes of data, right? So if the last backup was completed and you just lose your node, you could potentially lose data. So asynchronous replication allows you to have up to 5 replicas of every primary node. So you only will lose the tail end of the data that hasn't been replicated, right? But still potentially lose. That's why we created MemoryDB for Redis. It's a fully durable database that is intended to be as a primary storage that is backed up by a multi-C transaction log. So what this does is we decouple the engine from the durability. And this is what this architecture shows, right? So I'm a very visual person, so it's always helpful to have like an architectural diagram that explains us this. Uh, so there's two ways to have Redis clusters, right? One is what we call the cluster mode disable that is only available on Elasticache. That means single primary, so you max out on vertical scaling. And if you have lots of writes or lots of data, well, that's not going to scale as much, right? So there's another protocol called Redis cluster, and that allows you to have up to 500 primaries. And in Elasticache, that's up to 1 petabyte of data. So that's in concept. We took it and got it into MemoryDB, and you can still go with a single node, right? So you, in this case, on this example, we have MemoryDB for Redis cluster with 3 nodes, 1 primary and 2 replicas, because we still want to have at least 1 replica, right, to be highly available. Because, like we just saw, everything fails all the time, so we need to be prepared. But how does it work, right? So we have a Redis client. As long as it's a Redis cluster aware client, you will be able to write a key, in this case, our key A, with a value of 100. That will go to the memory of the primary node. And this is the new piece that we added, the multi-AC transaction log that spans through 3 availability zones in a region. So the data will be synchronously sent to the log. Once we get the acknowledgement that it has been written to the 3 AZs, that's when we send an acknowledgement back. So that means your primary node and the log both have the same data and they're consistent. So that means the multi-AC transaction log becomes your source of truth.
Very
And
cool.
behind the scenes, you have replication asynchronously. So you also have guaranteed delivery of data to the replicas.
Yeah. So I mean, basically, a lot of people hear Redis, they immediately think, great, it's going to be highly performant, very fast, low latency, but I'm going to lose data potentially if something happens to the machine it's running on because it's all running in memory. Machine goes down, all my data is gone. You all approached that problem and said, no, we're going to make it so that you can have the same performance from a cache, but you can have persistent data on disk also. And that's kind of the draw of MemoryDB. Is that right?
That's correct. Yep.
Very cool. So you can use MemoryDB as both a cache and a primary data store. Is that?
That's an excellent point because at this point, right now that you have MemoryDB, you remove the cache out of the equation, right? So
Yeah.
that means you often need a durable store plus a cache. In this case, you have the cache speed, right? So you simplify your architecture by having a single service to both.
Very cool. So I think today, yeah, there you go. I was about to ask. Today we're actually here to talk about data tiering, right?
That's correct. Yep.
Okay. So
So
tell
yes,
us what's that? What is
yeah.
data tiering?
Well, like I said, we work backwards from what customers asked us, right? So we understand that having data at all times in memory, it's expensive. So data tiering comes in as a feature on MemoryDB that allows you to have um, very distinct distinction of data, right? So an extension of your memory. So you have an attached NVMe SSD on this instance with a new instance type that we introduced. So we have support for R6GD instances that are from the Graviton family. So that means you have 4 times as much RAM, like in this graph that we have. We have the R6GD 8XL instance type with 32 cores, 12 gigs of network, and 209 gigs of RAM, plus 796 gigs of SSD, giving you a total capacity of 1 terabyte in a single node.
All right. So tell us this. When should I use data tiering and how can it help me?
Yep. So you have the ability, like I said, to distinguish what data is often used. So the way that this works is that um, I actually have a slide that explains the architecture behind the scenes, right? So you have data that is often used, right? So that means about 20% of your data will remain in memory at all times. All of the keys at all times in memory. That way we can detect when you have a certain key or not. And then this new tiering engine will spill data from memory to disk automatically for you. You still have the same concepts of the Redis keys, right? So they each have a TTL, and then you have the max memory eviction policy that will remove data, for example, the volatile LRU. That means all of the keys that do have a TTL or no eviction at all. What that so the data, the tiering is to an extension of your memory, pretty much, and it's completely transparent for the Redis clients in your application. So when would you consider it? It's very clear, for example, when you have a use case that has historical data. So you have like transactions, uh, purchases. So all of those are going to be different keys, and the older they are, they're going to be automatically spilled to disk. And then if you ever want to go and see, oh, I don't remember what I bought back in January, for example. So you can always go and get it, and the tiering engine will detect that that data is sitting on disk, will retrieve it, put it back to memory, spill something else, and give you back a response.
Oh, Robert, that's awesome. You know what? I think people are asking us in the comments, where's the demo? Let's hop in.
Oh, okay. So let me just really quickly tell you what do you gain, right? So that extra capacity allows you to have up to 60% cost savings for storage. So that means, for example, I have an example of the two instances that are the same size in terms of memory. And as you can see, we have an hourly price of 61 cents on the XL with R6G and 92 cents on the R6GD. So what that means is you have almost 5 times the capacity, giving you uh, pretty much a cost saving that will do about seven thousandths of a dollar per gigabyte used. So this is where you the why you will do it, right?
Oh,
Yeah,
Cost
that
savings.
perfect.
provides a lot of value on the cost savings. It's good to see that chart up there.
Yep. And yeah, let's go to this demo. So you will see two different clusters that I've created before, and then we'll actually go over and create one. So this is a MemoryDB for Redis cluster that is all in memory, right? So I have 10 different nodes because I needed a capacity of over 100 terabytes, right? So it's pretty much an apples to apples in terms of data. And this is a one shard MemoryDB data tiering cluster, right? So I have two nodes in this case. Like I said, we will always recommend to have a replica. And I can go to my console so we can see the response times. I already tried running it a few times. So as you can see, this is my MemoryDB only all-in RAM requests. I'll run it again, but just so you can see that it's consistently giving us about over 250,000 requests per second with a response time that is an average 360 microseconds, right? So very well down from the millisecond response times. And this is a data tiering um, cluster where we are getting about 133,000 requests per second and on average um, 700 microsecond response times. So bear in mind, this is a single node and these are 10 nodes, right? So as you can see, there is an added latency of 3 to 400 microseconds per request, but still below the single digit millisecond.
I
So
love it. So this, when I was checking this out, something that struck me that was really really incredible about all of this was I don't have to do anything except turn it on. Basically, like
exactly,
I don't have to change any lines of code. It and it's going to figure out my access patterns as I use my cluster. Basically, it's going to say, hey, there's been a long time since you fetched this out of the database, move it into a more affordable storage tier, right?
that's
And
correct.
it just saves me money. Like, that's amazing. I love it. We had a question from chat, Robert, actually, about the compatibility with Redis modules. So can you use Redis modules? Like, I believe the question was specifically around Redis JSON. Um,
Okay, excellent question, because we do not have compatibility with the modules themselves, but we do have support for JSON, right? So we have all the uh, 10 built-in data structures that Redis supports out of the box. And we do also have support for JSON as a native data type as of May. I think you were back then in this on air presenting that. So we do have
yeah,
that. Yep. And it's
yeah.
all compatible with the JSON path support, right? So all the commands that you can run for with using the JSON path structure, you can still use them as well.
I love it. So, you know, obviously moving data over to a cheaper storage is super attractive. I wanted to ask any circumstances where I shouldn't turn this on. I mean, it sounds like I probably should, unless I have a very specific reason.
Now, it is very important to distinguish that your workload can afford that extra latency, right? So as we can see, with these same instance types, you get 138,000 requests per second, right? And with the all in memory, you're getting pretty much twice as much, right? So if you're very, very sensitive on throughput and latency, that's when you require to have all data at all times in memory. So this is more when you have a clear definition that some of the data can be warm, right? So not necessarily hot. So you have a very distinguished workload that you have hot data and warm data.
Very cool. Very cool.
Yeah.
And I remember again, I was looking at this and talking with you before the show. So it doesn't actually move it back into in-memory storage unless if I never fetch that data again, right?
Excellent point. Absolutely. So the TTL concept still applies, right? So the time to live of every key. So if you put a key, like I said, for example, logs, right? That could be a use case that you can very well store in memory for fast access if you want to make a like a dashboard, and then you will store it in a very cold storage like S3 for the data lake, right? And so that means that your data lake will have all the data at all times forever, and then this in-memory store will have it as well durable, and but you never fetch it back, right? So you didn't watch the logs from last year, for example. The TTL will run its course, and then once that key it has to be expired, it will delete the data from both memory and disk.
Very cool. Very cool. Well, Jasmine, I know we've got other guests that we've got to get to. Robert, there was an incredible addition to MemoryDB. If I want to get started, do you have any good recommendations for those who, like our friend from the audience who had not heard of MemoryDB yet? How do I get started? What do I go do today?
Just go to your AWS console and get started. We have one instance type, the T4G small, that you can get started for 2 months for 750 hours per month for free, and up to 20 gigabytes of data written, right? That's our other dimension that we charge. And regardless of how many requests, that's great, right? So you can have 100 10 megabyte documents or 1 million kilobyte documents. It doesn't matter. You will just store keys and that's it. Like no read writes extra cost for, you just pay per node.
Nice.
And in this case, you can start with 2 months for free, and you will have the JSON support. And then you can always, once you feel comfortable, they can always go to one of these data turing instances. For example, they start with the Excel instance type because we do require extra cores, right? So we don't want to make Redis any slower. So that's taking a core. And then this steering engine is running on a separate thread. So Redis is still performant. And then the tiering is going to do its job of spilling data back to disk.
I love it. And Giselle just dropped a link in chat for us too. Lots of demos, tutorials, good landing page for MemoryDB to go get started. Go pick your favorite programming language. Go get Redis SDK and connect up to MemoryDB. Once you get it up and running in your AWS console, sounds that simple, right, Robert?
It is, yeah, and all Redis compatible, right? So the one thing, as you can see on my screen here, when you connect to it, you do get like, an error of you don't have ability to use the config or the cluster commands, right? That's what the control plane does for you as a managed service. It will take care of your nodes, replacing one of the nodes if it fails, all of that goodies of having a managed service from AWS. And with data tiering, we introduced a new set of metrics. So you can also be aware of how many bytes are getting written or items are written or read from disk, right? So you will have those here. As you can see, I have 3 rows on the data tiering one and only 2 rows of the most important metrics to look at in MemoryDB.
Lovely, Robert. Now, I always like to say 2 months for free. It's for me, for sure. Anything for free is for me. Yeah. So go and try MemoryDB. Robert, we've got to move on to our next guest, but thank you so much for joining us today. And we hope to see
Robert.
you back.
Oh, thank you. It was a pleasure.